This video is on trigonometric ratios. The word trigonometry comes from two Greek words meaning triangle measurement. If I know that two triangles are similar, then I know that the ratios of the lengths of their corresponding sides are equal. I can use this to find a side length or an angle measure of a triangle. So for example, in the diagram below, triangle FGH is similar to triangle JKL. Therefore, we know that the ratio of FH to HG is the same as the ratio of JL to LK. If I know the value of the ratio for triangle FGH, then I can use that to find the value, use that value to find the length of the side in triangle JKL. This is the main idea behind trigonometric ratios. The three right triangle trig ratios you need to know are sine, cosine, and tangent. The sine of an angle is the ratio of the length of the side opposite the angle to the length of the hypotenuse. The cosine of an angle is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. And the tangent of an angle is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. These ratios are abbreviated SIN, COS, and tan. Please do not pronounce them as sin, cos, and tan. That's the quickest way to drive a maths teacher crazy. They are sine, cosine, and tangent. Oops. So in the diagram below, lowercase a is the length of the side opposite angle A. So if I were standing at angle A and looking straight out, that side is opposite and the length of that side is lowercase a. B is the length of the side adjacent to angle A. Now you might say there's actually two sides that are adjacent to angle A, but C, because it's opposite the hypotenuse, is always the hypotenuse because it is opposite the right angle. So even though C, or side AB here, is adjacent to angle A, it's not considered to be the adjacent side, it's actually the hypotenuse. So the sine of angle A is opposite over hypotenuse, or A over C. The cosine of angle A is adjacent over hypotenuse, or B over C. And the tangent of angle A is A over B, opposite over adjacent. So why is this so important or helpful? Every angle that has the same measure as angle A will have the same value for the sine, cosine, or tangent of that angle, no matter how large or how small the triangle is. One way to remember these trig ratios is SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. So SOHCAHTOA. Let's take a look at a couple examples here. So for the triangle below, I need to find the sine of angle J, the cosine of angle J, and the tangent of angle K. So to find the sine of angle J, I'm going to imagine I'm looking here at angle J, and I'm looking for the opposite and the hypotenuse. So the side that is opposite angle J is 5, and the hypotenuse of this triangle is 13 because it's opposite the right angle. So the sine of angle J is 5 over 13. The cosine of angle J is going to be the adjacent over the hypotenuse. So with regard to angle J, 12 is the length of the side adjacent, and 13 is the length of the hypotenuse. And lastly, I need to find the tangent of angle K. So if I'm in angle K, since I'm looking for the tangent, I'm looking for the opposite over the adjacent. So opposite of K is 12, and the adjacent is 5. And remember, 13 is not adjacent even though it's right next to angle K because it is the hypotenuse. So here we have two triangles and it says find the length of the missing side of each triangle and round to the nearest hundredth. So I have a 25-degree angle, and I have one leg is 18 and one leg is x, and I don't know the hypotenuse, which is actually okay. As long as I have the angle on one side, I can figure out the other sides. So let's figure out, in relation to this 25-degree angle, x is my opposite, and 18 is my adjacent. Now I want to ask myself which of my three trig functions uses adjacent and hypotenuse. I'm sorry, adjacent and opposite, and that would be tangent. So I'm going to say the tangent of a 25-degree angle, remember we always do sine, cosine, or tangent of the angle, is equal to the opposite, which is x, over the adjacent, which is 18. Now I just need to solve this for x. So I'm going to multiply both sides by 18, and when I do that, I get that x is equal to 18 times the tangent of 25. And plugging that into my calculator, I get that x is approximately equal to 8.39. So the length of that side is approximately 8.39 units. Let's take a look at the second triangle. Here I have a 70-degree angle, and in relation to the 70-degree angle, well actually in relation to the whole triangle, x is my hypotenuse, and 15 is my adjacent. Looking back at SOHCAHTOA, I realized the trig function that uses hypotenuse and adjacent is cosine. So I'm going to do the cosine of my angle, which is 70, and that's equal to the adjacent over the hypotenuse. Now this one's a little trickier because my x is in the denominator, so in order to solve this equation I need to do two steps. I'm going to start by multiplying both sides by x, and that's going to give me x times the cosine of 70 is equal to 15. And now I'm going to divide both sides by cosine of 70. Remember, cosine of 70 itself is a number. Cosine is not a thing. 70 is an angle, but the cosine of 70 is actually a number. So that gives me that x is equal to 15 divided by the cosine of 70. And then when I plug that into my calculator, I get that that is approximately equal to 43.86. So that's approximately the length of the hypotenuse of that triangle. So if we know the lengths of two sides of a right triangle, we can use an inverse trig function to find the measure of the angle. So suppose we're not given the measure of any angle other than the 90-degree angle, and we need to find a measure of that angle. And if we have two lengths of two sides, we can do that. So using an inverse trig function looks like this. So if I say that the sine of angle A is 3/5, then I can say that the measure of angle A is equal to the inverse sine of 3/5. This is not read sine to the -1 power. That's the inverse notation. So the measure of angle A is equal to the inverse sine of 3/5, or sometimes we use arcsine language. The measure of angle A is equal to the arcsine of 3/5. This means, what is the measure of the angle that has a sine value of 3/5? So let's take a look at a couple examples here on how to do that. So we need to find the measure of angle A to the nearest degree. So I'm going to go ahead and mark angle A here. In relation to angle A, 6 is the opposite, and 20 is the adjacent, and the side that's not marked is my hypotenuse. So the trig function that uses opposite and adjacent is tangent. So I'm going to say the tangent of angle A is equal to the opposite over the adjacent. Or I'm going to rewrite that the measure of angle A is equal to the inverse tangent of 6 over 20. You can reduce that fraction if you want, but you don't have to. In other words, what is the measure of the angle that has a tangent value of 6 over 20? I'm going to do this in my calculator. I'm going to hit second or shift and then tangent and then put in 6 divided by 20. When I do that, I discover that the measure of angle A is approximately equal to 17 degrees. Let's try this triangle here. So again, I'm looking for the measure of angle A, so I'm going to mark it. In relation to A, well actually in relation to the whole triangle, 15 is my hypotenuse and 3 is my adjacent. The trig function that uses hypotenuse and adjacent is cosine. So I'm going to say the cosine of A is equal to my adjacent, which is 3, over my hypotenuse, which is 15. Or I can rewrite that, saying the same thing. The measure of angle A is equal to the inverse cosine of 3 over 15. And then using the second or the shift button and then cosine of 3 over 15, I get that the measure of angle A is approximately equal to 78 degrees. Remember, what that means is, what is the measure of the angle that has a cosine value of 3 over 15? So in this video we took a look at trigonometric ratios, sine, cosine, and tangent, what that means with respect to a right triangle, how to find the length of a side of a right triangle given certain information, or how to find the measure of an angle of a right triangle given certain information.